Morning, Becca. How's it going?
It's going good. How's it going with you?
Good. It's a lovely morning over here in Iowa.
Where are you in Iowa?
Just north of Des Moines, in a suburb called Ankeny.
Oh, okay.
Yeah.
I've been there one time, but
Oh, really? That's awesome. Most people haven't.
yeah. When I was driving to Oregon from Pennsylvania, I stopped in Iowa for like a tiny smidgen of time.
Nice.
So, I don't think we can hear you, Paul.
How about now?
Yep.
I have two places where I do this. One's at home, which is now, and one's in the office. And I only have one camera that's external to my laptop. So if I forget to bring it from one place to the next, then I have to reset all the configurations. But, I have a second camera on order, so we'll see.
That's good.
All right. We have three eager people with questions. Questions?
Hi.
No.
I've been having trouble with the homework assignment.
Which one?
I think it's the Mogi source model one.
Okay.
Sharing my screen might be the easiest thing here. I think like changing the variables, I think I've got that. Like again, output, that makes sense. But then my graph,
That doesn't look good.
I know.
Yeah, it's not great.
I don't know why it's doing this. I mean, like if the star is in the right place, like that's something, and the scales are correct. Like those are the ranges I was searching over, but I don't know what's going on.
Wow. Can you scroll back up to the code? Actually, can you put them back to the way that they were in the beginning and run it again? It doesn't take long, right?
The
parameters
sure.
back to the way they started.
So just go back to this one.
See if we can.
And I've done that a few times.
Okay.
But maybe this time it'll work. I don't know if you want to look at that.
Is it running?
Is this all running, Kira?
Oh, you want to run? Sorry. Okay, should I run the plot?
Yeah, we want
The
to.
original plot too.
Okay, so that looks good.
Yep, yep, that one works.
All right, so you were asked to vary now Z and V, right?
Yep.
And fix X and Y.
Hmm.
Go back and show us how you varied V and Z and fix X and Y. It's possible that it's right, but it shouldn't look right.
Yeah, no, I don't think it looked right. One of my office mates is also taking the course and he got like a reasonable graph, but we couldn't figure out what was wrong with mine.
0.6, 21.8. Okay. Now you're gonna do.
This one was like 2.3.
I don't think you need the semicolons on that XS and YS lines.
Okay.
Could be something.
Maybe I'll use it from there. And then that's fine. I guess I can change this.
You're much more thorough than I would be.
I think it's easier later. What are we doing? C, comma, volume, and then well, these should. Okay, I think that's all of it.
Yeah, you might want to change
more or
this
less.
Y to- You might want to change X and Y and to V and Z in the print statement if you're gonna go with it.
Yeah.
Also in loop.
Okay. Sure. I guess I made it kind of tiny, but it works.
Why don't you change the X and the Y to V and Z, so Z and V, so we print statement
Yeah. Oh, I thought I did.
It did. in the loop there.
Yeah, there are just a couple of those print statements.
That's good. At least won't confuse us as we debug. So it's looping over Z.
It is also looping over V, I think. Like this is what it looks like in, I wonder if it's just like the decimal output.
Yeah,
It did
in
that.
the formatting string that you're passing for that print statement, you're telling it to round to only 2 places.
Like
In the
well,
Hmm.
it did this for the like example 1 too, though. I don't know, like if I run, wait, that's the wrong one. Right, when I do this one, it also looks like it's only varying one of them.
It's interesting.
So if you go back down to the homework session, what does the plot look like now? Or will you have to change a bunch of stuff for that too?
Yeah, hold on.
We've got to put that double quote back in on the line above.
Oh yeah, thanks. I'm gonna try this. The axes might be backwards. They are, wow. That's different.
Let's see.
Um, Oh, that happens sometimes too.
Okay, can we go just back to the original calculation of the error surface, just a little bit, just to look for some typos. So you set the XY, you loop over Z and V, Z and V, and XY. This stuff looks right. Misfit is a two-dimensional array of zeros with the right dimension. C and D. So in the print statement, seems like the print statement should be indented one more level if you want everything to be updating. Try that again. Not that it's going to change the outcome, but
Oh, yeah, but it does.
Yeah.
Yeah.
the print's better.
So now it is actually, we can see that it is looping through everything.
Yeah.
One thing I was wondering in that nested for loop, I think before the variables you said are xv and yv, where do you use that in the code in that indented block?
They're never there. Like they're never used. It uses, I think if you use ZS of K, if you make that XV, it's the same thing.
That's an interesting
But-
choice.
Yeah.
Hmm. So yeah, so we can pop it. Okay, that at least makes sense. So you tried putting XV there instead of ZS and YV instead of VS. That didn't make any difference.
Yeah. We can try it again. Let's see XV. So that's running. I'm gonna put this.
Hmm. Weird.
Also, I haven't gotten a graph that looks like this one before.
One thing I know I always run into is sometimes when you manually set the color map, it might not work for some data. So in the ax1.image show call, try just removing the CMap argument.
This one.
Yeah, CMap equals CMap. Okay, no, that wasn't the problem.
So you got a different result, but you were the parameters that you just typed in by hand now the same as the ones you typed in last time?
They're close.
So I want to say,
Yeah, the result that I got is the same. Yeah, and they're pretty close. I think I did like a wider search, but
I see.
pretty similar.
Well, it looks like you're doing the right kind of thing.
That's good.
Well, I'm going to actually run it. See if I can get a different result myself.
Mm.
Maybe we should, if there are any other questions, well, I'm gonna be running this. Maybe there's some other questions. From others, while we're figuring this one out. And if we can't figure it out in this hour, Franz will be on at 10, and it's an hour of homework review. We can figure out, he can tell us what we're doing wrong. See what we're doing.
Hey, this is Alex. I just signed on. What is the problem with the homework that you're discussing?
Well, Kyra is having a trouble getting a nice looking misfit function on the solution to the grid search for the Mogi source.
Oh, so the plot, just the plot.
Well,
Yeah, here I can show.
it seems
again.
like it's just the plot, yeah.
Because I got the same numbers.
Yeah, I don't know. My plots
Okay.
look kind
I
of like
see.
this.
Okay.
So Alex, what does your plot look like?
Not like that.
Okay, good, that's good.
I mean, I can show it. This is what mine looks like.
There you go.
Yeah, that's reasonable.
Now let's look at your code, see what the difference is.
I mean, I pretty much use the same plot as above. I just changed the extent and then what's actually being plotted.
I thought that's what I also did.
It kind of looks the same, yeah.
What range of values did you use for the actual air source calculation?
I used a pretty big range. See here. Yeah,
Do
I have
those
to
look similar
configure
to yours,
make-
Kira?
It's certainly better sampled. It's a denser grid, maybe that's the difference.
Kira, I think you're muted.
Sorry, I tried it with bigger ones and still kind of got weird, similarly weird graphs. I don't know.
You might want to try just changing your inputs to match
Yeah.
hers and seeing if, that seems to help anything.
Can I stop sharing? Or do you still?
Do you want to just scroll up real quick so I can grab your input parameters? Great, thanks. Yeah, you can stop sharing now. And once again, anybody feel free to ask other questions while we kind of troubleshoot this one.
Hello. I have question regarding the same problem. How can we assume the right range of these values? Because I used another values and I have another curve. So how can we assume the right range?
Yeah, I think with a lot of this parameterization stuff, it's going through a couple of iterations and finding one that seems reasonable. I would start with the values that are already coded in. So, you know, for instance, right now for the Z's, you have the default value is 2.58 and the volume is 0.0034. So start with making kind of small bounds around those values and kind of expand out from there would be my suggestion.
Okay, thanks.
So I ran it again. I got a slightly different answer, which was interesting, but and a different graph, but it's still kind of wonky. This is what the graph looks like.
That actually looks pretty good.
Oh,
Like a little bit better, at least. The
yes.
flipping of the bands is weird, but you're getting a general shape that looks better.
It just seems quantized in this the volume parameter in the plot, at least. So sorry, it says depth, but
Well, I think the ISCE
yes.
values are swapped on here, but
Yeah.
yeah. I mean, I can keep fiddling with it and just bring it up in the homework review.
Yeah, I would suggest, you said somebody in your same lab group has a working version, right? I would try copying over their code and backing out, trying to get to the source parameters you're trying to get to from there. It's always nice to start from working code.
Yeah.
I just ran it myself and got a more reasonable looking surface. I can share that if you want, and it looks a lot more like Alex's. And I got fairly quantized surface when I first plotted it myself. I ran it with 0.001 as a spacing, and I just reran it with 0.0001 as a spacing, which gave me a lot more points, and that seems to have fixed a lot of the quantization in the volume component. So Alex has looked a lot smoother than this even, so there's still something funky with the plotting, I think. But anyway, I think it might just be your grid definition somehow, and then how that interacts with the plotting. But the other thing I did, just to be careful, was make sure that I renamed all the variables to be appropriate for the thing I was searching for, just as a way to make sure that I wasn't missing something. Not that it mattered, but I think we checked all of yours, it looked right. But I went through and just made sure that everything was named appropriately and plotted appropriately. That way I didn't miss anything when I was doing the code modification. And it seemed to work. So I think there's just some typo someplace that we missed by looking at it, or the grid search is too coarse or some combination thereof. But it does work, should work. I think you're doing the right kinds of stuff, so I don't think there's any conceptual issue here.
Good. Thanks for trying. Yeah, I'll work on it.
We have a question in the chat. Can you please explain how to generate tropospheric models? Not sure exactly.
Yeah, so generally we don't generate them ourselves. We rely on models from other people. So there's this organization called ECMWF, European Center for Medium Range Weather Forecasting. And they produce an operational product that's available either as a service for a fee if you're, I guess, a money-making organization, or for free if you're a researching organization. And they have various products with different latencies and different resolutions depending on your needs and your resources. There's a whole bunch of different products. So ECMWF is one place to go. There's a number of other agencies around the world that generate their own weather products. And some of the layers in that can be basically the refractivity as a function of altitude. And then for a radar system like this, you have to know where the satellite is, know where you're looking on the ground, and then you have to integrate along the path that refractivity to get the total integrated path delay for your weather model. And there are a number of programs that do that. I think there's going to be a module later in this course that talks about that. So perhaps the details of it you should save until we get to that module. Does that make sense? Maybe, oh yeah, there's tropo and ionosphere corrections is on Thursday at 11 o'clock. That's where you'll learn the tools that are available for both tropo and ionosphere corrections, module 4.2. Other questions? Alex, did you join because you had questions or just because you were interested in the office hours?
Oh, just interested. I don't have any specific questions yet.
Okay, that's good. That's dedicated.
I've got a quick question. It's more of a logistic question. So I had a little bit of trouble basically like setting the cookies up for the net RC. And so I had a little bit of trouble later.
Okay.
I was just wondering if maybe I could share my screen or something.
Of course.
Okay.
That's what we're here for.
Cool. So, sorry, I ran this the other day, and I just had a question about, so I ran this in the terminal within OpenSARLab, these, and inputted my Earth data password and, or username and password here, and then ran these. Do I need to put this in the actual notebook and then call it from the notebook? Or I just I ran these and it didn't seem to work.
You ran those and it didn't seem to work?
Yeah, well, yeah, when I was following along on the on your, or actually no, it was the strip map tutorial yesterday. I had to input my own password and everything because it didn't call it.
I had that same problem, and it seemed almost like it was calling the nets RC file incorrectly. So you're talking about the strip map one, the very first cell?
Yeah. I was just curious if it was because I didn't set this up right here. So just I guess if I ran this, I ran this in the terminal. Was that the correct thing to do in OpenSARLab?
That's what I did.
Okay.
You can see the netrc file, and then if that line is there, it worked.
Okay.
It is a hidden file, so it's probably easiest to see it from the terminal.
I see. Okay.
But if you're in the right folder and you type vi and then space netrc, then yeah, it should be able to see it. I don't know if there's an easy, oh, so yeah. Did you do, it should be dot netrc.
Oh, yeah, right.
So you can exit by
Is it Q?
doing Shift ZZ, like a 2 capital Z's will exit the file. Yeah.
Okay.
Yeah, so it is there. So I found with the strip map, the notebook, for some reason, when it tries to open the net RC file in that first cell. I changed that line slightly and it was able to read it. But I don't think that is necessarily the point of this notebook, as long as you can still manually insert your password. Everything else worked fine.
Okay.
So I'm
Yeah.
confused. Your netrc file doesn't have, it just has a generic login and password in it, right? It's not actually set up yet properly. Right? Didn't you just,
Oh, right. Yeah. So I need to go in and edit it with the password and add all that. I
Well,
see.
yeah, those lines that you were showing in the other window were supposed to create that for you. So if you go back to what you were showing originally,
Okay. Let's see.
Yeah, I would just use quit or Q.
here you go.
Okay. So if I go back in here.
No, not that. You had showed a set of commands to create the netrc file.
Oh, right. Yeah. Here.
Right. Yeah, so this configure your username and password for authentication using a netrc file. So those 4 commands should have created the file. You're supposed to type in what your, see where it says user ID goes here.
Right. Yeah.
You put that in, and password goes here, you put that in, and they give an example down below.
Right. I thought I did that, but I might have forgotten to change this or something and copy and paste it, but I'll run that real quick. And
yeah, why don't you just try it with some fake thing so you don't have to tell us your password, and see if you can create it.
okay. Sorry, let me just pull the Zoom stuff out of the way.
We'll just bring up the terminal. Again.
Should I just copy and paste this in? And
Well, try typing something other than password goes here. Just try type Q. It's fine.
type Q?
No, type copy and paste the line, but before you hit return, go back and place something in there like password goes here. Just change that to something else.
Okay.
Like Q. Just type it, delete it, and type Q. Put the quote back.
Okay, let me start over. Sorry about that.
That's good. QE is fine. Just now hit return. Now type more space more space dot netrc. Okay, so your change was made. So now what you want to do is do the same thing without us seeing it, but put in your user ID and your password for netrc.
Okay. Sounds good.
And that should fix that problem.
Thanks. I'll run that and let you know.
We have a question in the chat asking about, could somebody go into more in-depth explaining the various acquisition modes of Sentinel-1? Seems like mainly tops versus strip.
Well, the question seems to be about radar satellites in general. I think it's hard to say what the most common acquisition mode is anymore. Clearly, Sentinel-1 is generating more data than any other system in the world by far because of the nature of its observation strategy. So the continuous observations over most of the globe every time it goes over, at least once, since there were 2 satellites for a while. So in terms of the just sheer volume of data, it's clear that TOPS data from Sentinel-1 is the most common. The simplest to understand and process is StripMap, which you saw yesterday. And the earlier satellites, such as ALOS-1 and RadarSat and NBSat and ERS, all those satellites primarily were, well, they were either only StripMap mode like ERS, or they primarily focused on StripMap mode. They had other modes like ScanSAR, Spotlight, but those were used for special cases typically. For ALOS 1 and 2, there's also quite a bit of ScanSAR data. ALOS 2 has a strategy of acquiring shall we say, blanket Earth coverage using ScanSAR several times a year, and then focuses using StripMap on more local areas. Often, if it's polarimetric observation, StripMap is preferred because it's easier to do, and you don't have the so-called ambiguity problems with it. The other thing is another system is called SAOCOM that is using TOPS mode mostly, but also has StripMap modes. So it's hard to say what the most common modes are from that perspective.
What is NISAR going to be again? Or its main operating mode, at least?
Yeah, so it's going to be effectively StripMap with a full swath. It's this special technique called scan on receive using a digital beamforming array with a big reflector. The way we're going to operate it from a user perspective, it'll just look like a very large StripMap system. There's some interesting quirks with it. Because of this technique, when you transmit, you have to turn off the receivers during the transmit event, and because it's such a wide swath, there's a number of places in the swath where that you have to do that. So you would have these permanent gaps in the swath if you didn't do anything to try to fix that. What we end up doing is changing the PRF basically from pulse to pulse. That moves the gaps around, and then when we create the image, it smooths all that out and creates a continuous image. But from a user perspective, it'll look a lot like StripMap data.
Wow, that's really interesting.
Interesting and not easy to do, it turns out. All right, we're getting close to the top of the hour. Any last questions? Well, if not, I'm gonna drop off to get ready for my 8 o'clock meeting. And we'll see you all at 10 o'clock.